So let's try a problem based on this concept that we've just learned. This is problem number 1032. Problem 1032 in your book. So the question reads, a golfer hits a ball giving it a maximum height of 20 meters. If the ball lands 130 meters away at the level from which he hit it, what was its initial velocity? Neglect air resistance, of course. So this is a simple problem. So a golfer hits the ball. Okay. And it's at the same level as the from where the ball is hit and where it lands. It reaches a maximum height of 20 meters. So we got to find its initial velocity u. Remember I said when we're asked to find u, we're asked to actually find ux, uy, and the angle theta. Alright, so let me draw the theta here, which will probably make more sense. So you can, that's easy to visualize. And it is ball lands 130 meters away, so this is 130. Okay. Alright, so let's write the information that's given. First, I'm going to concentrate on the vertical aspect of the journey. So imagine a person imagine you're standing here looking this way. How would you see? And imagine you're standing really far. You're standing really far, and you're looking this way. All you would see is the ball go up 20 meters and then come back down. Okay, this is assuming you're standing really far and also you're standing exactly in line, in plane with the trajectory of the ball. Okay, so so that's what you would see, and that is what we're going to take advantage of. The one thing is the ux and uy, the problem becomes much easier if you decouple them, if you separate them out. You solve for, the way you go about this problem is you solve for one leg of the journey, which is the vertical aspect of the journey. You get some data from it. You take that and apply to the horizontal part of the journey, and then that completes the picture. Let's see how. So vertical part of the journey, vertical. Okay, and because this is all vertical, I will use the subscript y, and if I don't use the subscript y, please assume that it is y. Okay, if I forget to write it, then still assume that it is the y aspect of the journey. So I'm going to write sy, so it's 20 meters. Okay, let me write uy first. Uy, we don't know, we need to find that. Vy is 0, because what happens when it reaches, like I said, mentioned before, the velocity uy, it decreases as it goes up to this point. At the peak, the vertical velocity is 0, and then it starts increasing on the way down, but at this point the vertical velocity is 0. So the vertical velocity is 0. Okay, and of course acceleration we know is g is 9.81 meter per second square. Okay. Alright, so from this, what formula we can use? We can use v squared minus u squared is 2gs or 2as. Okay, and because it's a vertical part of the journey, I'm going to write the y here in all of these. Okay, so this is 0 squared minus u y squared equals 2 times 9.81 times sy is 20. So uy is 19.8 meters per second. Okay, so what happens is it reaches, so we know this part now. Okay, and we have found out that just based on the vertical height it has reached, okay, that's all we needed. Vertical height it has reached. So in some way it really doesn't matter if the ball was hit at what angle, or as long as we know the vertical velocity and we know the height, that completes the picture. Or let me rephrase that, as long as we know what height this projectile has reached, we can treat this problem simply as somebody throwing the ball up vertically, reaching 20 meters. Okay, this time is exactly the same, and this velocity, u velocity, is exactly the same as the uy velocity in this case. Okay, all right, let's also find the time it takes for it to complete this journey. Okay, we know the initial velocity, we know the final velocity, okay, initial, final, and we know acceleration. So find time. V equals u plus at, and then we're still dealing with vertical aspect, so I'm going to go put the y here. Okay, this is 0. This we just found is 19.8. okay, minus, okay, 9.81, minus because it is going up, it is decelerating. Okay, and time is what we need to find. So when you put the numbers in, you get time is equal to 2.02 seconds. Okay, so I reiterate, it really doesn't matter if you're throwing it like this or if you're throwing it straight up and down. As long as the height is the same, it takes the same amount of initial velocity to reach this height or this height, and it takes the same amount of time to reach this height throwing vertically or reach this height in this trajectory. There's no difference. I don't know if you have done this before, but or if you have come across this experiment, like if you have a table, if you have two coins sitting at the same distance from the edge, throw one coin gently and then one with a lot of horizontal velocity. Both coins will fall on the ground at the same time, okay, provided that both are shot at the same time, one gently, one with a lot of force. The only difference is that the one with a lot of force or a lot of horizontal velocity covers a lot of horizontal distance, but vertical distance, they take exactly the same time to cover it. Okay, okay. So we have done the vertical part of the journey. Now let's look at the horizontal journey. Okay, all right, something to note here. This is 20, so this is the halfway mark, 20 meters. This whole thing is 135, so this is 65, this is 65. Okay, so the time it takes to reach from here to here is 2.02 seconds, and the time it takes to reach from here to here is also 2.02 seconds. And if you think of this ball reaching from point, let's call this A, B, C, the time it takes for the ball to reach from point B to point C, cover this horizontal distance, is 2.02. It is also the distance to go from B to D, right? That means from the height of 20 meters, right? Because when the ball hits C, what has it accomplished? From B to C, it has accomplished what? It has accomplished 65 meters in the horizontal direction, and it has also accomplished 20 meters in the vertical direction. Okay, so we can use the time that it has taken to go up as the time it has taken to come down, right? Because if a ball takes 2.02 seconds to reach a certain height, it'll take exactly 2.02 seconds to reach from that height back to the ground. Okay? So I'm going to use t is equal to 2.02 seconds. Sx is the horizontal distance, is 65 meters. Okay, and ux we don't know. Okay, we don't know the velocity. Okay, so we know, and in this case, like I said, the horizontal component of this velocity is the same throughout, has not changed one bit. So if the velocity is the same, then the acceleration is 0. So in that case, you can use the formula distance is equal to speed into time. You could also use the formula s equals ut plus half at square, but then of course acceleration is 0, so we don't even need this term. And because it is horizontal component, I'm just going to say this. Okay, so s is 65, ux is what we have to find, tx is 2.02. t is the same, call it tx, t, ty, they're all the same. Okay, because that takes 2.02, or from here to here it takes 2.02, right? From that also takes 2.02. Okay. So ux is 65 divided by 2.02 comes to 32.18 meters per second. Okay, so we know, what do we know? We know uy and we know ux, so we know the complete picture. We have the complete picture. So the initial velocity when the ball was thrown, it has ux is equal to 32.18 meters per second. Vertical is 19.8 meters per second. Now the resultant is u is equal to square of ux square plus uy square. So square root of 19.8 square plus 32.18 square. So when you do that, you get 37.78 meters per second. Now this is just the magnitude. We have to find the angle. Okay, we have to find the angle theta. So that is theta is tan inverse the vertical component uy divided by ux. So that is 19.81 divided by 32.18. So you get theta is equal to 31.6 degrees.